Okay, so today we're going to be dealing with some more graphing kind of stuff, intervals of increase or decrease, and you should be able to notice it relatively easy, okay? So when we're talking intervals, it's just like where it changes, so if it's a steady increase, that's an interval, and then if it changes slightly, like right here it goes steady, and it changes a little bit more tipped, and here's a more obvious example of that. It's like, okay, boom, okay, boom, then drop. Okay, so we're just going to talk about like how those change and what they actually kind of look like. So interpreting a qualitative graph. So we're looking at a speed train here. An express train reaches a traveling speed of 150 miles an hour a short time after leaving the station and travels at this speed for an extended period of time. What does a qualitative graph of this distance the train that travels over time look like once it reaches its travel speed? So obviously it's going to be gaining speed because it starts at 0, right? And it gains speed, and then it'll get to its speed that it's trying to get to, and then it'll stay at that speed. So let's see what it looks like, because we're talking about time and distance, right? So we're not talking about its miles per hour necessarily, but it kind of equivalates to that. So let's draw a qualitative graph. A qualitative graph represents the relationship between qualities without really numbers. We don't really have there's no real numbers here. Identify the input variable and the output variable and the interval. So first thing that we have to do is identify the input. The input in this particular one is going to be time. Okay? So when it says over time, so a graph of distance over time, check it out, distance is over time. So that's a good indicator. This is our input, that's our output. When you see that, it's like over time, that word is going to be on the bottom because it's got to have the other one on top of it. So as it's speeding up, starting at 0, right, its distance traveled isn't nearly as far over time because it's slowly speeding up, so it's going to travel more distance as it's going faster. Something that travels 100 miles an hour is definitely covering more distance than something that's traveling at 50 miles an hour, right? So it's slowly picking up speed, and then it finally hits its max speed, which was 150 miles an hour, and then it's traveling a pretty steady rate. Over time, it's traveling 150 miles in an hour, so it'll be steady because it's holding that speed. Here it was changing, slowly getting to where it was, and then it just kept its speed after that. So identifying intervals, definitely went there to there, and then from there to there. Okay, steady intervals, definitely different. So this one's definitely, this interval right here is definitely increasing. That interval right there is definitely increasing, but there's a difference in them, right? So an interval is a period of time between two events or points in time. The second interval starts when the train reaches its travel speed. So gaining speed, hit its speed, and then it was steady. So the graph to the right shows an interval in the train's travel, which best describes the behavior of the train at this interval. So it's probably picking up from there, right? It was going at a steady speed, and it starts slowing down. So speed to time this time, okay? So, which best describes the behavior of the train in this interval? As time, what? As time continues, so as time goes up, continues, the speed of the train goes down. As the time increases, continues, keeps going, increases is the word they want you to use. As time increases, the speed of the train decreases. So as I'm going this way, this is going that way, okay? That's what we are looking for. So as it increases, it decreases. The function is, what are we looking for here? The function is a decreasing interval. Well, there's only one interval, so I guess we're just going to say it is decreasing. The function is decreasing. We don't have to say in an interval because it's not intervaled. There's just one interval in that particular one. So it's just identifying that one interval. Let's take a look at this one. Okay. The graph shows the behavior of a ball that a soccer player kicks to a teammate. Describe how the height of the ball and time are related in each interval. So, determine whether the function is increasing, decreasing, or at a constant in each one. Ooh. I wonder. Let's go back to this one. It's constant in this one, right? So this function is constant because it doesn't change. It's only the interval itself. If it had changed like it did here, that would be increasing. So since it changed into that interval, we would know that. But that's a tough one. We're going to come back to that. So, determine whether it's increasing. Let's look at the intervals. We're looking at height and time, right? Time goes on the bottom. So the graph shows the behavior right here. So looking at the first interval, which is right there. So if we're comparing two things, distance above ground to time, as he hits it, what happens to the distance above ground? It goes up. So he kicked it, and it goes up, and then into interval 2, it starts going down, and then it'll eventually stop. So, determine whether the function is increasing, decreasing, or constant. So it's definitely not going to be constant because its height is constantly changing. The function is increasing in interval 1 and decreasing in interval 2. So, to describe this, as time increases, height increases, and then from here on, as time increases, the height decreases. So the graph shows the behavior of a Skyla skateboard at the skateboard park. In which interval is the function increasing, decreasing, and constant? So interval 1, decreasing, 2, constant, it's right there, 3, increasing, 4, decreasing. All right, let's take a look at this one. Describe the relationship of quantities. In which intervals of the function increasing, decreasing, or constant? 1, increasing, so it's 3. 2 and 4 are just flat, so they are constant. And 5, decreasing. So let's go back. Is that one increasing, decreasing, or constant? Well, constants are flat, so this one's got to be doing what? Decreasing. All right, now we got that answer. This is write a scenario that the graph above could represent. So let's talk about this. As time continues, the distance traveled continues to go up, right? But what happens here? Time kept going, but distance didn't. What did they do? They took a break. They sat down. They stopped moving in some way, shape, or form. And then they increased again, and then they sat down and stopped moving. And then what happened? They must have come back, maybe. So this is what I'm going to say. I'm going to say it was like a hike. They were hiking. They took a break. They were hiking. They saw some flowers. They picked some flowers in that general area. Didn't move very much. And then they went back home. That's how I would do it. This one's really easy. It's just kind of fast, I guess you would say. So again, we're talking about what's happening here. Time is almost always increasing because you can't stop time, you can't reverse time. It just pretty much is always increasing. And then the big change is what's happening to the distance. As time increases, the distance increases. As time increases, the distance has no change. That's a constant. Then as time increases, the distance decreases. Time increases, distance doesn't change. Time increases, distance goes down, decreases. It's really not too much craziness going on there. It's just a couple of words that you might need to familiarize yourself with, like increase and decrease.